So this is number 7 again. There's some confusion over how we get an angle. So remember that this thing is doing this. Agreed? We're all in agreement on that. Okay. So let me make that line very, very faint, because we're going to superimpose a bunch of stuff over it. So there's its motion. Now what we're told, and I'm going to use our sort of standard red for a resultant vector, is that it has a known VF. So we can all agree on that, yes? Okay. If that known VF is not entirely on the x or the y, would it be true, I'm asking you rhetorically sort of, that there would be an x component to that final velocity and a y component to that final velocity? Is that a true statement? Some of you look like you want to vomit at that. So the question is, well, wait, do I have to do this for everything now? Yep. Because anytime you've now got something that isn't on just the x or the y, we are now breaking it into components of motion, velocity, acceleration. So yeah, anytime we have something that is not purely x or purely y, it's made up of both. And so that's why we learn to break apart vectors. So in this case, what we know about this thing, so yeah, at this point we've got that sort of final triangle, and that's why the problem says, hint, consider the components of final velocity. So the thing that we know is that there was an initial velocity on the x. Was there an initial velocity on the y? No, because these are kicked, flicked, and pushed. Okay, these are kicked, flicked, and pushed. So what that means, because we know that there's no acceleration on the x, the initial velocity on the x equals the final velocity on the x. Does that make sense? Are we good with that? Absolutely. So we know if we go back and do the little, two axes lifting, VIX, A sub x, well, acceleration on the x is equal to 0, which means the velocity on the x-axis is not changing. Well, if it's not changing, then whatever x velocity it started with is the same x velocity it ends with. So VIX equals VFX, which also equals the entire VI, because of the fact that VIY was equal to 0. Now, did the velocity on the y-axis change? Yeah, there's this funny little force acting on it. I don't know if you've heard of it or felt it at any point in your life. It's all about how attractive you are to the Earth. Gravity. So this object is accelerating on the y-axis. We've got acceleration on the y equal to negative g, negative 9.81 meters per second squared. And so let's see, where do we go from there? Well, can we find VFY? So, right now, what we want is to find VFX, because we need VI, and we know that those two things are equal. So far, so good. Okay, so we know we want to do that. Well, if we had VFY, we could actually just use Pythagoras here. VFY, depending on which angle we're considering, is, if we're considering this angle, the landing angle, then VFY is equal to, well, hold on. Okay. sine theta equals opposite VFY over VY, hypotenuse. Therefore, sine theta VY equals VFY. So, I mean, we've got an expression for that. Can we find the value of... Is there an easier way to do this? Thinking it through. Because we can find VFY very, very simply. And once we have VFY and VY, which we were given, we can find theta. Do we even have to do that? I don't think we do, huh? Because if we have VFY, we can just use Pythagoras and solve for Vx. Yes? Dazed? Stunned? Huh? Yeah, absolutely. Yeah. Absolutely. We don't have to use sine, do we? Okay, so here's the other pathway. Let me set this aside. We'll just put that right there. So if we have this object and it is just straight up dropped with a VI y of 0, could we find the VFY after some known distance? Yes. So we could find the magnitude of VFY if we take VFY squared equals VI y squared plus 2a delta y. Yeah, I see what you're saying, because I put that expression for sine theta Vy in for Vfy. But if we're only analyzing the motion on this axis, we're just going to get the magnitude of Vfy, and then we don't actually have to do the sine theta Vf equals Vfy. Okay, so I led you down a merry little chase through the garden. But that's okay. It's good practice. All right, so then Vfy, the magnitude of Vfy is equal to the square root of, well, 0, 2a delta y. Okay, so that would give us Vfy. Then we have two sides of a triangle. We can find the third. Oh, that's much easier than I thought it was. Okay. You better with that?
Yes.
Feel like less like you want to throw up? Wunderbar.